kidnapping people. Also, can I join off with somebody? What is the username? Or is it like?
All right, it is 10:30 and we only got Joe in Discord. And I'm hoping some people are on the YouTube channel. Let me just check over there. It's on. We got one person on YouTube. All right, well, I'm gonna start the class anyway. Okay, oh, Aaron's here too, so very nice. So I'm gonna get started here. So what we'll do today is, I'm just moving on to section 7 of the module that we have been talking about for the past 2 days or so. So unless there are some questions, we're gonna get started with this. And section 6, is a permutation generator, and then section 7 is a combination generator. So with section 7, I chose not to use omega, just because, otherwise, we have.
Yeah. You have the YouTube stream?
Sorry?
Link to the YouTube stream?
Oh, the link to the YouTube stream. Sure. Let me make a clone of that and post it here. There we go. Sorry about that. I forgot about the posting the stream on YouTube. All right. So getting back to section 7, and the stream should be going already. Once you click on that link, that should be ongoing already. Just kind of behind by 15 seconds or so. So we are getting a start on section 7 because that's also what the homework is about. So we'll talk about section 7 first, and then I'll talk about the homework assignment, and I'll give you guys some ideas of how to do it. So section 7 talks about how do we generate all the combinations, and this one is related to the lotto game because the lotto tickets are combinations and not permutations of choosing 5 of 47 numbers. So u of I is kind of like this. And you can see how u of 1 of x is defined as this. So this is kind of the base case because we want to use a recursive definition again. And you can always kind of get it down to u of 0 if that is kind of what you want to do. So let's go ahead and think about u of 0. Okay, whatever suffix is used here, this 1 or 0 or I or whatever it is representing the number of trials. Okay. So let's just think about a very specific case. So let me start up my whiteboard equivalence, and we'll take a look at a particular example. So give me a second here to start this up. All right, so there we go. And let's go ahead and just start with uppercase U, okay, uppercase U of 0, and we'll give it a set of A, B, and C. And I just want to know, what this is supposed to return. In other words, I want to look at all the possible combinations of an experiment that has 0 trials, and with each trial I'm going to pick one item out of the bag that initially has A, B, and C in it, and it is also without replacement. In other words, after I choose one thing out of the bag, I do not put that thing back into the bag for additional trials. So the question is, is pretty kind of, it doesn't seem to make sense, right? Because I'm giving you a bag, it has 3 items in it, and I'm asking, okay, what is the outcome or outcomes if I choose to not to choose anything out of the bag. So what do you think is going to be the answer to this particular question?
It should be an empty set, right?
Okay, so here's a fairly obvious answer. Okay, but the question is it correct? Is it an empty set, or is it a set of an empty set? So now we have to kind of think about this and ask, okay, which one is right? Is it a set of empty set, or is it the empty set itself? Okay, so what do you think? Now, if this is an empty set, in other words, in the first case, I'm just going to comment over here. This is basically telling us that there is no outcome, right? Because U of something is the set of all outcomes. So if the set of all outcomes is an empty set, that is telling us that there is no outcome. As opposed to the second one, that is telling us that there is one outcome, and the outcome is no item is selected.
Well, going off what we learned yesterday, myself, it was an empty tuple in the set.
Yes.
Which was U sub. The second version you have there, the set of a set, would imply that there's an empty set inside the ABC, which there's not, so I believe it's the first one.
So you believe it is an empty set and not a set that has an empty set as an element?
That's correct.
Okay. Let me see. Do we have any other discussion going on? Nope. Okay, so the text channel has no further discussions. The correct answer is actually the second one. Okay, so this is the right answer. Okay, so now the question is, why is this the right answer? Why is it a set that has an empty set in it? It's because there really is an outcome. The outcome is just that there's nothing. So okay, imagine that you have two bags. Okay, so imagine that you have one bag that has the original items A, B, and C in it, and then you have an empty bag where you're supposed to put the selected items into. Okay, so now you have two bags, and the question is, if I say, okay, don't choose anything out of the first bag and put it into the second bag, you still have an outcome. The outcome is you end up with an empty bag. So the empty bag, that is the outcome in this case, is here, because the empty bag is your actual outcome. Now, if I say, let's use big U of 1 instead, then you have three possibilities. So you end up with, okay, on one side you have the original bag that has the items A, B, and C, and then on the other side now you have three possibilities. The first possibility is a bag that has item A in it. The second possibility is a bag with item B in it, and the third possibility is a bag with C in it, right? So that really is kind of the deal, right? Because this is why you always have at least one outcome. It's just that in this case, the only one outcome is a bag that has nothing in it. I'm not sure whether this is okay with you guys, whether it's making sense or not, because you still have a bag that is supposed to store whatever you have selected. It's just that when you are not picking any items out of the original set A, B, and C, then you just end up with an empty bag, but it is still an outcome. Is that okay? This is also kind of why 0 factorial is defined to be 1. Alright, so hold on a second here. I'm gonna, let's see, where's my volume control? Alright, so let me just kind of turn my mic down just a little bit. There we go. Okay. So are we good so far? Joe is typing something. I'm gonna wait a little bit here.
Why am I using this crappy?
It's kind of like that, yes. 0% is still a chance. Give me another second here. I just need to tell my son to kind of lower his voice. Joe is typing some.
So essentially, the empty set indicates an empty bag, then, and so it would be the set of no values, which would be what sub-zero is, right?
Okay. Can you repeat that, please?
So the empty set would be equal to a set of no values, which is what the sub-zero is, but we still need a set to contain the empty set, so that's why it's an empty set within an empty set.
That is correct, because the outcome or the result of the big U function is supposed to give us a set of outcomes. But there is an outcome. It's just that that particular outcome has nothing in it. And that's why the outcome, the single outcome itself, which is the empty set, is itself an element of the set that is the container of all the possible outcomes.
Okay, yeah, that makes sense.
Yeah, so I guess if I presented this a little bit more carefully, it would avoid some of the confusion, because the definition of U of I of X is representing the set. So it is itself is a set of possible combination outcomes of an experiment. But each combination outcome itself is also a set. So that's why the big U of something is always a set of possibly one or more sets. Let's take a look at something else, okay? We'll just kind of work this out by hand instead of using the definition. So we'll go ahead and look at U of 1, okay? And we have the same original items to choose from. So we have A, B, and C as the choices, okay? So this time what I'm asking, okay, now I'm gonna end it first just so that the notation looks right. So so what this is asking is you start off with a bag that has A, B, and C in it. And I'm asking you, if I let you choose one item out of the bag, what are the possible outcomes of the entire experiment, which is basically just the outcome of a single trial. So yeah, go ahead.
Oh, I was about to say we'd have 3 outcomes: A slash subset, B slash subset nothing, and C slash subset nothing.
That is correct. So let me fix this first. So the answer to this question is we have a set, and inside we have a set with just A in it, a set with just B in it, and a set with just C in it. Because this is representing the outcome where you choose item A out of the original bag, and that's why you only end up with A in the quote-unquote destination bag, the bag that you're supposed to store things that you have selected. And you can do the same thing with B, and you can also do the same thing with C. Now let's take a look at yeah, go ahead. Yeah.
So with yesterday, it was an empty tuple. Why is it that we use an empty set to show the outcome of sub-zero instead of, say, like an empty tuple?
Because in a combination order is not important.
Then in what case would we use the tuple?
When we are looking at permutations.
Okay.
Okay. So that's why, in an earlier lecture, I believe it was the one before the last one, before the previous one, I mentioned that combination has to do with the set notation, because ordering is not important. And then permutations have to do with tuples, because ordering is important. And that is exactly why omega 0, is a set that has an empty tuple in it, and U of 0 is a set that has an empty set in it. And we got something in the text channel. So would U1 be the cardinality of the set itself, of the original set? The answer is yes. So now let's take a look at U2. Okay, so U2 of A, B, and C. Okay, which has nothing to do with the band. You guys are way too young to know what is U2, but I'm kind of that generation. I'm dating myself.
It's free for a few weeks on iTunes.
Or Spotify. Yes, Spotify has a really, really good collection, curated collection of U2 songs, and some are good and some are kind of like maybe, but they have some hits. So anyway, in this case, U2 of A, B, and C is asking, what is the set of all the possible outcomes if I decide to choose 2 items out of the original bag, and put those 2 items into my quote unquote destination bag, but ordering is not considered to be important. Okay, so in this case, we go to here and we say, hey, we can choose A and B out of the 3 items and put it into the other bag. We can also put A and C into the destination bag, and we can put B and C into the destination bag, and that's it. Okay, this is all that we can specify as U2 of A, B, and C. So some people may ask, but when we did the omega thing, okay, we also have BA, CA, and CB in it. So what about those particular items? Well, they are, remember, we are not dealing with tuples anymore. We are dealing with sets. So the curly braces clearly indicate that these are all sets. So when you specify a set as AB as elements in it, it is equivalent to a set that has BA just listed in the opposite order. But if they are both sets, they are considered to be the same, and you cannot have duplicate items in a set. So that's why we are not going to list the set of AB and the set of BA both inside the set of the outcomes. So is that okay? I mean, does everybody understand why this is different compared to the other one? I mean, why the U notation is a little bit different from the omega notation. It starts off being quite similar, okay? Because in the case of subscript 0, we are just changing an empty tuple to an empty set. But and also, when we look at the subscript 1, it's kind of the same deal, right? We are just replacing the parentheses with braces. But when we look at U2, it starts to look kind of different because the duplicate items are removed. But now when we look at the last one, okay, so let's work on U3 of A, B, and C. So this time, it is kind of a stupid question because, I give you a bag, an original bag that has the 3 items in it, okay? And I'm asking you, to perform 3 trials in this experiment, where each trial is to reach into that bag and grab an item, right? So now you go like, that's not very, that's not meaningful because, that means I'm just going to get all of the items from the original bag and put it into the other bag. You are absolutely right, okay? So that means we have one single outcome as the result. Because it doesn't matter whether you choose A and then B or C and C and then, or you choose A and then C or B, or you choose C first and then B and then A. They're all considered the same because only membership is important, where the ordering inside the bag is not important. So we basically just end up with one single outcome in this case. So are we still doing okay so far with...
Yeah, that makes sense.
Okay, very good. So now the question is, does this have anything to do with the C and the P notation thing? Remember we talked about the combination notation, right? C of, NM is starting off with N items and choosing M out of it. Is it?
Yeah.
Okay. So there is a very interesting connection. It's actually not even particularly interesting. Okay, so I'm just borrowing things so that I don't have to retype a lot of stuff. Okay, so let's just look at the cardinality this time. So we are not concerned about the actual outcomes. I just want to know the cardinality. Okay, so and let's change this to M, and then we'll change this to just a particular set of X. Okay, and we'll also use a notation, and we say N is the cardinality of the set X. That's just a definition. So N equals to the cardinality of X is just how we define N, just so that we don't have to refer to cardinality of X all the time. And then we are looking at UM of X. Okay, that's basically just asking if we decide to choose M items out of X. Okay, and we are only interested in counting combinations. What would be the number of combinations in this case? Well, that has to do with, that's basically choosing M items out of N. And we talked about those notations already. So if I go back to the notes here, okay, because I totally forgot about how to put N over M, in big parentheses. So I'm just going to cheat here and just look it up. And it is done right here. Okay, so right click, show math as tech command. It's not pronounced as text, it is just tech. I cannot really properly pronounce it because it's in Greek, because it is it's tau epsilon chi. It's just that it is it also looks like TEX in English. So it really is just choose, okay, and choose M in curly braces. Okay, so I'll do something that's even more lazy. Select, copy, and then go to my text editor and paste. There we go. So you can do the same thing, if you're interested in entering math equations in a way that kind of resembles how I do it over here. Tech, just like technology. Okay, cool. All right, so if n is defined to be the cardinality of X, then UM of X, if we're just interested in the cardinality, it would be the same as N choose M, or otherwise known as the combination, the number of combinations of choosing M items out of N to begin with. All right. So I'm hoping this is kind of illustrating, using a very distinct example, with only 3 items to play with, what the big U notation is about. Okay, it is about generating the combination outcomes in an experiment where each step is to choose an item without replacement from a certain collection. So are we good so far with what the UI of X is actually representing? Just using through the examples.
Yeah.
Okay, excellent. So now the question is, but how do we generate it, right? You can use one of the 2 base cases. For all practical purposes, this one is appropriate, because most of the time, why would we be interested in experiments that has 0 trials? Okay, very, very rare. Okay, there might be some cases like that. But if that is the case, we can always kind of go back to this one and use this to stop a recursion as well. So it's kind of up to you, okay, to decide, whether you want to use U of 0 as the end of the recursion, or you want to use U of 1 as the end of the recursion. Kind of the same deal as omega 0 versus omega 1, okay? So that part is not super important, okay? The really important part is, if I just give you UI of X, how are you going to define that recursively, using basically smaller, U of something? So this notation, I understand it looks super ugly, because we have nested big U notation in it. But it's not really quite as bad as it seems. Okay, so let's go ahead and expand this just like last time, because I think it's the way I did it last time, using an expansion, kind of step by step, can be useful to kind of illustrate how this works.
Am I being stabbed while I'm AFK?
All right, so now we go to accessories, mousepad. I choose not to use equations, because that's just a whole lot more. It takes some more time to do it. Okay. All right. So let's use an example of just U2, and we'll keep using ABC as our original set of items to begin with. So now we just deal with one level of loop at a time. So I'm just going to do, I will unfold the outer loop first. In other words, we just want to enumerate, okay, go through all the items of X to begin with. So the first time E equals to A. The second time, okay, let me just use a next line, because this way I don't have to deal with indentations as much. So the second time, I choose E equals to B, and then the third time I choose E equals to C. And the rest, okay, it's still kind of a big U notation here. So this sub big U notation is going to be S is in U I minus 1. Okay, I'm going to put in parentheses I minus 1. But I minus 1 this time is just 1, right? Because I is 2 this time. So I minus 1 is just 1. So it becomes U1 of what set are we talking about? Whatever X is, which is A, B, and C, but we have to get rid of the item that is chosen this time, which is A. So we are looking at B and C in the set this time. Excuse me. And then we utilize this notation. So I close the parenthesis. This parenthesis is closing this one over here. And this is just what item we are enumerating over. But once we enumerate over that item, then we are generating a set that only has one particular element in it, and that element is E in a set and unioned with S, which is S is generated over here. Okay, so I know this looks really bad, okay, because it looks super confusing. And I'm just matching parentheses right now.
Can you type out union instead of having?
Huh?
Can you type out union for? Because that U in the middle is union, right?
Yeah, this is a union operator.
Yeah,
makes more sense.
All right, so the second line looks about the same, except we remove a different item in the set to begin with. So in the second one, we remove B, so we would have A and C left. And in the last one, we remove C, so we would have just A and B left in here. Okay, so let me just kind of pause here and make sure that we all understand how it is unfolded, how U2 is unfolded into 3 components, and they're all unioned together. And it's all based on this particular definition.
So taking that E equals A, S would be equal to the set of BC?
No, S is an element of big U 1 of BC as a set.
Okay, so it could be, if E is A, S could be B or C.
Well, we'll deal with that later. How about that? We'll deal with that later. But we just know that S is an element of whatever this set is generating.
Okay.
Yeah, because what I have highlighted here, which is equivalent to this portion here in the general definition, is giving me a set of sets. So every element of U1 of something is itself a set. So we know S itself is a set, and that's why we can put it into a union operation, because otherwise it doesn't make sense. And also we know what E is in this time. In this case, with E is A in the first iteration of the outer loop, E is B in the second iteration, and E is C in the third iteration. So I just want to spell out as much constant as possible and not refer to the variables.
But that's not a
All right. So are we okay so far?
Yeah, it makes sense.
Okay. And I'm just double checking on the text channel. Nothing is, no, there are no questions over there. So now we go like, okay, we can't really go any further until we know what is U1 of, just BC, okay? So we look at this, and let's just not to choose the cheap way out of using,
forgot how to kick.
the end of recursion condition, which is right here, because there's no recursion here. This big U notation does not depend on big U of something else. This U here is just a union. It's a iterative union operation, but it is not an application of the U function that we're trying to define here. So let's not use this one. Okay, so we're going to say we're not dealing with U of 0, so we have another recursive definition here. So we have E equals to B in the first iteration, and then E equals to C in the second iteration. And then with each one, we also have a loop. Okay, this big U here is specifying a loop. And oops, I take it back. We're talking about this U here. Okay, the inner one. So with this U, we are looking at S is a set itself, but it's inside of U0 this time. And because we have chosen B already, so we only got C as an item when we apply U of 0. And after that, we are basically looking at the item that is already chosen for for E, which is B, union with this S over here. And now we want to union with the next item, which is going to look almost exactly the same thing, except instead of using B, we would use C over here, and then instead of C here, we would have B here, because C is chosen, and as a result, we only have B left as the only choice. Okay, so this is really just the same expansion as U2 of something, except this one is U1 of something. So now we finally got down to U0 of when C is the only thing left in the bag, but I'm not allowed to choose anything, right? So this we know is a set that has an empty set in it, and the same thing applies to the case when I have a bag with only B in it, and I am asked to choose nothing out of it. So that means the only outcome that is possible is I end up with an empty set or an empty bag, but nonetheless, that is a outcome, and that's why the empty set as a outcome is inside the set of outcomes. All right, so are we good so far? Getting from U2 and expanding into U1s, and then getting down to U1s and expanding into U0s, and then U0s, by definition of what we just talked about today, is the end of recursion. And we know exactly what U0 would look like, regardless of what set is given to me in the first place, because I am not allowed to choose anything out of it. So I just want to make sure that we are okay at this point with the expansion of items. So I'll give you guys a moment to think about it, and if we're good, then we can kind of go back a little bit, and then we go forward again. So I'm just waiting for any questions,
Yeah, that makes sense.
Okay.
Actually hit someone.
And what about the rest of the class? Are we all doing fine with this? Okay. I'm not seeing any feedback. All right. So, I'm not seeing any feedback other than Aaron's feedback. So now we can go back, right? So now we go, okay, so now we can kind of resolve what this one would look like. Okay, so I'll copy and paste it. So this way, we have a track record of what it used to look like and what it does look like now. Because we know what U0 of C looks like. So we take this, copy, And then we just use it to replace U0 of C, which is what is happening here, right? So I put it here, and I was missing one close paren actually in all of these cases. And I just have to kind of add that close paren. There we go. I think it looks, yeah, that looks good now. And also U0 of B is evaluates to this by definition. So I copy that and I paste it to wherever I refer to U0 of B and paste it here. Okay. So now I look at this and go like, it looks like, there's only one element that I can iterate through in this particular set. So that means, the only thing that this S can be is an empty set, right? So now we copy and paste this, okay, instead of doing in-place change. So I copy and paste this and go like, hey, this loop here, it will only go through in one single iteration. So, we might as well just kind of look at the actual outcome of this big U notation here, or this union loop, okay, so to speak. Because the only value that I can bind to this particular S variable here is to bind it to the empty set. So that means, we are looking at this, okay, that's one single loop. So that means, the first line really evaluates to this, and then the second line is going to evaluate to, because S can only be an empty set, okay, and so the second line is going to evaluate to this over here. All right, so this one, I think, you might want to spend a little bit of time to think about this, just because it may look a little confusing because, yeah, so I'm just going to let you guys take a look at this and see if you have any questions, because, this one is a little bit trickier.
All right, let's go.
Can you copy and paste it and far away? You're not done yet.
Huh?
Never mind.
No. Who's this?
Let me try something else, because I can. I'm gonna try this, as a way to remove my son's, voice from the recording. Aaron, are you listening through Discord, or are you listening through YouTube?
Discord.
Discord? Okay. Yeah, Discord should have his voice removed already, because I'm using the denoised channel.
It's sometimes audible if he speaks really loudly, but for the most part, not so much.
Okay.
Oh shit, I actually got you.
Yeah, I can hear that too.
I mean, his voice is very distinct from yours, so it's not too distracting.
Yeah, still, but I think he doesn't have to be screaming that loud in his game.
I mean, it's League of Legends. It gets intense.
Luki, my students can hear your voice through my mic. Okay, can you just have to speak softer, okay? Can you do that? Thank you.
So, looking at it, so we're going back up now, right? So we replace our U of 0, which previously was S. Oh no, because we have our U of C, so we replace our U0 of C with the empty set, because that's what it is.
Right, so
now, union that with our B, which brings it back, and so that makes B union of an empty set and C union. Okay, yeah, I get it.
Yeah, and yeah, just it's because this is specifying a loop too. This is specifying a loop where we each iteration is S as a variable, going through every single element in this particular set here, right? because
Right.
yes, because this specifies a loop, and the U outside of it tells us what do we do with the result of each iteration, which is, in this case, we are just doing a union of the result of each iteration. So, but because this set only has one particular element in it, which is just the empty set, so I just didn't bother to expand it into its own loop structure, because we only have to go through one single iteration. And when we go through that one single iteration, the variable s is bound to the only value inside the set, which is the empty set. And as a result, the one thing that we do with the variable s is we just say, okay, we'll make a set out of b, okay, because e is b in this particular iteration of the outer loop. So because e equals to b, and the way we generate a value out of this iteration, for the outer loop, for the inner loop, is to union with the set s, and s can only be empty. So we just say, okay, since the only iteration will give us this, we just say, okay, this is the actual result of the outer loop when e equals to b. I'm not sure whether that's working or not.
Yeah. So
Okay.
And the other one, because E equals to C, we get C union empty set.
Yep. Exactly. So let me see if there are any other questions. Nope, there are no other questions in the text channel. All right. So now we do some, simplifications. So we just, let me just kind of copy and paste. So we'll copy this and paste it here. And then we ask, what is something unioned with the empty set? Well, you get the original set back, right?
Right.
So that's just go like, oh, that is a silly thing to say. That is also a silly thing to say. And voila, we get back, U1 of BC is really, okay, so now we perform the actual union, okay, because we can take this just one step further, because we can actually go ahead and perform the union. All right, so when we perform the union, let me give you guys two choices here, okay? What is supposed to be the result of this thing? Okay, so let me put another equal here. So I'll give you two choices. So do we end up with this, or do we end up with this? That is the question.
Well, since we're unioning a set of B with a set of C, would it not be the first one, which is a set of B and a set of C?
That is correct. So the first one is the correct answer. This one is the correct answer, and then this one is not a correct answer. Is that okay, everybody?
Yep.
Okay, so we get rid of the wrong answer, and also get rid of this intermediate step here, because that's already in the previous derivation. So now we just say, oh, so U1 of a set BC is really just giving us a set back, where each element is a set of an element that we were given with in the first place. And that kind of makes sense, right? It makes sense at several levels. It makes sense from the perspective of what we just saw here, on the whiteboard. It also makes sense from the perspective of how I define the end of recursion, which is kind of a nasty way to look at that. But that's because, if I don't know what x is, okay, then I need to use a loop to go through every single element of x, make a set out of that element, and then make a union of all of those, all the set of sets, right? So that's why it looks kind of nasty, but there's no other way to specify it, okay? So now getting back to our example, we just figure out what is U1 of BC. Now I'm pretty sure, well, when I said I'm pretty sure, I'm just kind of speculating, that no one really wants to go through all this trouble to find out what is U1 of AC, or go through all this trouble to find out what is U1 of I think AB is left. There we go. So am I correct about that assumption that we don't really want to go through exactly the same steps as this portion here, just to find out what is U1 of AC as a set and U1 of AB as a set? Is that correct?
Yeah, it makes a lot of sense.
Okay. So I'm just going to jump to what they would expand to. So U1 of AC is a set itself, and then inside that particular set we have A in a set, we have C in a set, and U1 of AB would be a set where inside A is in a set by itself, B is in a set by itself. So now we have U1 of BC, U1 of AC, and then U1 of AB. So that means we can now plug those things back into the original U2 expression. Okay. And we go like, woohoo, we know what this one looks like now. Okay, so I'll go ahead and just copy and paste. So copy and paste. And then we copy and paste and copy and paste one more time. Okay.
Oh wait, Doge is back.
There we go. Okay. So are we good so far? Because all I did was to look at U1 of BC and say, oh, okay, since we found the actual result of what is U1 of BC, I put it back into this place, and I do the same thing with U1 of AC and then U1 of AB down here. So now we have a few more steps to go, okay, but I'm going to only go through one of them, okay, and then the rest, is going to be pretty much the same thing all over again. So now we want to say, since this variable s is iterating a set that has multiple items this time, so maybe we should look at this and expand it and unfold all the iterations of this loop, which is what I will do next. So we'll take a look at this sub-expression, and then we say, okay, what is this sub-expression going to look like? Well, we know it has two iterations, because in the first iteration, s as a variable is bound to the set with just b in it. And in the second iteration, s as a variable, or the iterator of this loop, is going to bind to the set of c, just like that. Is that okay? Does everybody understand why in this loop we have exactly two iterations? And in the first iteration, well, I mean, the ordering is not important, okay? But in one iteration, s is bound to the set with only b in it. And in the other iteration, s is bound to the set with only c in it.
Yes.
Okay, excellent. So now we go like, okay, what happens when s equals to the set of A, okay? What are we generating, for the overall union, which is this guy, what are we generating here? Well, what we are generating is a set that looks like this, except we know what s is now. So we just say, okay, it's not just, any s, because we know in this iteration, s is just a set of with b in it. And then in the other iteration, s is just a set with c in it. All right, so if we know this much, we can now say, okay, let's just see if we can work this out. Okay, so I'm going to copy and paste again. So this time when I copy and paste, there's no need to keep mentioning s equals to b, in a set. There's no need to mention s equals to c in a set. Okay, that really is just for quote-unquote debugging purposes. I just want to show you why we have that iteration. So now we look at this and go like, oh, by the way, this is also unioned with the second item. So this union operator has to do with this big U specification here. The S in a particular set is specifying a loop, but the result of each iteration of the loop is union together because of this big U notation here. So now we first evaluate, okay, what is the set of A union with the set of B. Okay, that is not too hard. It's just AB here, and this one is not too hard either. It's just AC in a set. So are we doing okay so far with this step here? Because we have A set with A as an element in it, we have A set with B as an element in it. So the union is going to say, okay, we'll put all of the elements of both sets into one single set, but without duplication. But since A and B are distinct, they will both get into the new set, which is the union. And the same thing with the set of A and the set of C. All right. So when we perform a union of these two sets, okay, we go like, are they the same thing? Nope, they're not the same thing. So they would become distinct elements. So the set with AB is one element, and then the set with AC is the other element. So are we good so far? Okay. All right, excellent. So, all right, so now that we know what this one expands to, we're gonna kind of not go through all the same trouble to specify the other ones. So I will just go ahead and spell them out, okay? So we'll take this here, and I'm just gonna spell it out, but without derivation, why it expands to the end result. Okay, so this one is gonna end up as BA as a set and BC as a set. Okay, and let's work with the last one. So I'm skipping a few steps because the mechanism is exactly the same as the first one, so it's not going to be very exciting nor useful to expand, to go through those same expansions. So this one is going to be CA and CB. Now I know some of you are already noticing that, hey, we got BC over here and then we got CB over here. Is it okay? Yep, it is still okay at this point because the BC, or this portion here, belongs to this particular sub-expression, and CB, okay, is a part of this particular sub-expression. So they are of different sub-expressions, and we have not performed these unions yet, so it's not a problem yet. Okay. All right, so now we take this U2, okay, and copy and paste into here. And once again, since I already know that this sub-expression expands to this, so we take this and we just say, hey, we know what this is going to expand to. So we replace it with the result of our expansion. And we're going to get rid of this silly E equals to A because nobody refers to E anymore. And then we take this and we replace it. We replace this component with that because that's what it's going to expand to. And then we'll do the same thing with the last one. Okay, so we take out this. And just we say, and then we say it's going to expand to this. All right, so quite obviously, we are now kind of getting closer and closer to the final answer, okay? So the final answer, we know is going to be a set, okay? Because, the result of a union of a few sets has to be a set itself. But we also have to be careful this time because, duplicate items should not happen, right? We can only have one distinct value in the set. We cannot have multiple occurrences of the same value within a set. So the moment we say AB, we have to say, oh, BA is taken care of. We're not going to list BA over here. The moment we list AC over here, we basically have to say CA is not going to be listed here, because it would be the same as AC. And then the only remaining distinct item is BC. So once we have taken care of BC, then CB will be taken care of as well. So this becomes the actual answer to the original question. So the question is, wow, that is long, right? I mean, because the issue that this is long is because we are manually expanding a recursive definition that basically has nested loops in it. And that is why it is so tedious, okay? It's kind of tedious to explain, and then the terminology is also a little bit tedious as well, but it's kind of necessary. I thought about this for some time, and I could not find a easier or a simpler notation to express the same thing. All right, so are there any questions? It has been about an hour since the beginning of this class. Go ahead.
What was the final U sub we had? Are we going all the way to U2 or all the way up to U3?
I think we were only going after U2. There we go.
Okay.
Yeah, so we were only going after U2 in this case. And then someone might notice this and go like, but Tack, you talked about this at the very beginning of the class. Yes, I did. I did talk about it, at the beginning of the class, and this is the result of running what I would call an eyeball algorithm. In other words, I think about this, okay, I got 3 items in one bag, and I'm allowed to choose 2 things out of it and put it into my other bag, okay? But the ordering is not important. How many possible outcomes, not how many, what are the actual possible outcomes? I just kind of worked this one out intuitively, okay? It's the eyeball algorithm. It was not systematic. And then we talked about the end of recursion. Okay, so we talked about the end of recursion. Either you can use U1 as the end of recursion, or you can use today's definition here and use U0 as the end of recursion. So end of recursion is usually not too hard to deal with, but the recursive step is, okay? So the recursive step is, what if I give you a set X and I specify the number of trials as I? In general, okay, how are we going to figure out, okay, the set of all the combinations for such an experiment? So that gets a little bit harder to explain because I now need to introduce, a double loop in this case, right? Because, this is one loop, E in X is one loop, and then S in UI of something is the other loop. So I'm taking the result of a recursive call and then put a loop over the result of a recursive call, which by itself is also, I have one recursive call per iteration of the outer loop. And that is why this is kind of long and kind of tedious, because, this is the structure of the code to do it. All right. And guess what? That's your homework assignment. So this is your homework assignment. So now I'm going to switch gear. Well, let me first check whether people still have questions about the...
Can you put the text file in the chat?
Yes, absolutely. Let me save it first, and then I'll put it there. So we'll go ahead and save it in temp, and we'll put it in as 2020105-. I just like to put my text file kind of in a systematic way, date stamp followed by the class code. So there we go, and I'm attaching right now. Give me a second here. There we go, and I'll pin it too. And you guys can try to open it, download and open it, make sure that it opens okay. Because I'm using a Linux system, which means the text files on my side only uses a single line feed to end a line. But if you try to open it in Notepad in Windows, it might appear to be one single really long line. I'm not sure. Okay, if that is the case, you just switch to WordPad. Okay, use WordPad to open it instead of Notepad. And thank you, Aaron, for expanding it, and so that people can just copy and paste from Discord now. Cool.
Does it not have a line termination at the end of each line in Linux?
Does it? Yeah, it uses a single line feed, but without a carriage return.
Okay, interesting.
Yeah, so there are 3 standards, and this is great. Okay, this really tells us all the kind of cool things about the computer industry. In Unix and also Linux, because those two are fairly closely related, each line in the text file is terminated by a single line feed character, which is ASCII 10. In DOS, each line is terminated by a line feed, a carriage return, and a line feed, which does correspond to the 2 distinct operations on the typewriter, because if you have access to a mechanical typewriter, it doesn't even work on an electrical typewriter, but on a mechanical typewriter, okay, there are 2 mechanisms. One is called a carriage return, which basically puts the entire, shifting, mechanism, which slides left and right, and carriage return, returns the entire carriage, okay, horizontally back to the home position, and that's why it's called carriage return, or CR in abbreviation. But it doesn't roll the roller, okay? It doesn't move on to the next line, and that's called a line feed. So there are 2 distinct operations. One is called line feed, which is vertically, if you want to look at it vertically, is vertically, moving on to the next line. And then carriage return is more of a horizontal homing, operation. So in DOS, okay, for whatever strange reason, they decided, hey, we'll use a carriage return and a line feed. So you would see CR and then followed by LF, okay, as a representation of the line terminating characters. If anyone is using a Mac, then you will find out that, but it doesn't look right on a Mac, okay? Well, that's because on a Mac, they only use a single carriage return to terminate a line. So between Unix/Linux and DOS and Mac OS X, there are 3 separate standards to terminate a line in a text file.
So in C and C++,
Yep.
would we have the \n or the NL?
Yes.
Use NL? Or is that's part of the C++ standard library? So yeah, we have the \n. How would that be represented exactly?
So \n is supposed to only specify the line feed character, which is ASCII 10. So technically speaking, if you compile a program in C and it only terminates a line, with \n, it should not appear right, okay? Because the DOS terminal program is supposed to look at a \n as only to giving it a line feed, so it would basically jump to the next line but continue at the same horizontal position of that line as the previous line, I should say. So that would look wrong, okay? And sometimes when you do cat or type a file, that somebody gave you from a Linux system, and if you use the command called type in DOS, that's exactly what it would appear, because it's missing the carriage return necessary to return back to the beginning of each line, so that things will all line up on the left-hand side.
So it looks like a stair step, kind of.
Exactly. It would look like a stair, it would look like a stair when you go to, when you're heading down, when you move from left to right. Okay, that's one way to describe it. And that's really kind of strange, because but WordPad knows how to deal with it. Okay, so if it doesn't look right in Notepad, use WordPad instead in Windows, because I think WordPad is still distributed in all standard versions of Windows, and it will open it correctly. Fun stuff. So in a DOS and in a Windows environment, the proper way to terminate a line is to use backslash R, which is the carriage return, and then backslash N, which is the line feed. And this is also why in C++, using the control characters directly is frowned upon, and instead you have a EOLN instead. So you have to use a EOLN, as the end of line indicator, and that one should compile depending on which operating system you're using, and it would use the correct control characters to terminate a line.
Is that ::ELN or is it \ELN?
Sorry?
The line terminator.
In C++?
All right, well, in C, I'll work in both.
So in C, this is how we do it in Linux. And if you have a DOS system, technically you should use \r \n, and on a Mac it should be just \r.
Okay, interesting.
Yeah, but that's also why people strongly discourage people to refer to just the control characters, because it's not very portable. So that's why in C++, if I remember correct, it has EOLN as a constant that you can basically do you can use it at the end of a less than, when working with a stream, and that will basically use the correct one depending on what operating system you're using.
Oh, interesting.
Yeah, and then EOLN is nasty too, because it also unless you import the entire namespace, so technically you have to use the namespace ahead of it. I think it's IOS : Yep. Interesting stuff. All right, so let's kind of go back to the homework assignment, okay? Because your homework assignment is to do something like this, okay? And your homework is in the module. Oh, by the way, I have put in your score for exam 1 into the system. And as I was telling you guys on Tuesday, the class did really well. I mean, I just didn't know how well until I entered the scores, because I wasn't mentally tracking anything and when I was putting in the scores, but when I put it into the system, it's like, wow, okay, the class did pretty good. So exam 1 as a module is right before relations, because that's the scope, okay? Because the scope of exam 1 was up to and including Aleph null, but it did not include relations. So the second exam is going to start with relations. Let's see, discrete probability, there we go. So here is your homework assignment. It's due on the 12th. So you have 1 week to work on this, okay? It's you might see it as plenty of time, or you might see it as not enough time. So it all depends on how well you understand the recursive definition and how comfortable you are with recursion. And this is also why CISP440 is really a good co-requisite or prerequisite of this class, because without 430, most people do not have much exposure to recursion. All right, so here's the description, and I'm going to have to give you a little bit of code to start with, because the first part says parse parameters, and use argv, value 1 as a base 10 number of the number of trials per experiment, and use the second one as the number of choices for the first trial. Okay, so I'm not giving you a particular set, because the set is always going to be A, B, C, D, depending on the number of elements. Okay, so I just give you a number of elements and you know what set you should start with. Okay, the choices are represented by lowercase English letters. This means the number of choices can only range from 1 to 26. So argument 2, okay, can only be going from 1 to 26, because we only got 26 letters in the alphabet. All trials are without replacement. The number of choices of the first trial is greater than or equal to the number of trials per experiment. So in other words, you don't have to check for the cases where I say you only got 3 items to begin with, but I want you to have 4 trials, because that doesn't really make a lot of sense. The output should be organized in lines, whereas each line is representing one possible experiment combination outcome. So in other words, you have to deal with sets, and that's why the big U notation that we talk about today is going to be, well, perhaps important. Each combination output should appear once and only once in the output. In other words, I don't want AC to appear and then CA to appear also on another line of the output. Okay, so you have to basically play by the same rules as set restrictions. And then each line contains lowercase letters without separators. So no space, no commas, nothing. If the set only has A, B, and C as elements, just A, B, C. And then move on to the next line. The ordering of items on each line does not matter, which means if A, B, and C are supposed to be in the set, it doesn't matter whether they are listed as ABC, BAC, ACB, and so on. Okay, there are 6 ways to arrange it. But obviously, if you're doing this using a program, okay, it is likely that you would choose a way that it is in a systematic way. Remove any debugging message from your program prior to turning it in, because I know some of you like to debug programs using printf or putting something into cout, which, by the way, is not really the best way or the most effective way to debug a program. But if you choose to do it that way when you're debugging a program, it's okay. You just have to take out all the debugging messages before you turn it in. So here's an example. A.out is kind of the name of the executable. 2.3 specifies that we only want 2 trials, and the first trial has 3 choices to begin with, so that would be ABC, okay? And then the output would be AB, AC, and BC, okay? They don't have to be in this particular order. If your program outputs BC first, and then AC, and then AB, it's perfectly okay as well, okay? So the ordering between the lines is not important. The ordering of the letters within a line is also not important, but they need to be all there as they are supposed to. And then this part here addresses what programming language you can use. You can use Node.js, which is just regular JavaScript, except it runs on the command line. You can use Python, and you can use Python 2.6 or 2.7 or version 3. It doesn't matter which one, but you have to let me know which one you are using. Okay. You can use Java, you can use C, or you can use C++. Okay, so these 5 are the programming languages that you can choose to use. The source code is to be turned in. So don't turn in just the result, turn in your actual source code. Your code should not require any additional modules, libraries, or extensions other than what the language natively supports. So that means, you don't want to turn in your code and then you tell me that, oh, by the way, to run this code, you will have to use npm and install, these 20 modules before my code would work. Okay, so your code should work really natively. If you use code blocks, please turn in the zip file of the project folder. If the whole program is in a single file, and it needs to be in a single file, I think I specified that somewhere else. Yep, there we go. Write a single source file program. So you have to turn in the program in a single source file. If the program is in various files, okay, that part does not actually, apply, because I said that it has to be in a single file. The only time that it can be in multiple files is when you have a code blocks project. So the project file is by itself a file, and then you have your source file as a separate file. So that's the only time when the multiple file thing applies. All right, so now with the remaining 7 minutes or so, I am going to give you the shell code to deal with argv1 and argv2 and how to interpret those things into a base 10 number. Okay, the best way to do it is to use online GDB. Okay, so if you don't know about online GDB, just kind of try to get used to it, because it's actually a very, very kind of handy resource, because you don't have to install anything. All you need is a browser, and it seems to work with just about any browser that I have used it with. So it's very flexible. So the first thing you want to do is to change main so that it accepts multiple parameters. And the multiple parameters is argc, which is an integer. And then you have const char pointer argv. So that would be the first thing you need to do. And I'm going to take out hello world here.
What does that do in main?
Okay, so all this time, since CISP440, most of you were told that, okay, when main is the entry point of your entire program, but don't specify any parameters. It doesn't take any parameters. Well, that would have been a lie, because it takes on not only two, it actually takes on even more parameters. But since I have no use of the additional parameters, I choose not to specify those as the parameters. argc stands for argument count, and then argv stands for argument value. So the very first thing we want to do is to make sure that there are 3 of them. Okay, so don't do a single thing unless you have at least 3. So we say if argc is greater than or equal to 3, then we do the following. Otherwise, just don't bother and just don't do anything. If you want to report an error, okay, that's fine too. Okay, so you can say else printf and say need at least 2 arguments. And yes, I know how to count. I specifically say 2 in this case because the first argument is really just the path of the executable itself, and we just don't use it. Okay, so the first thing we want to do here, okay, is to do another printf, and we just say argv 0. Okay, argv 0 is %s. %s is kind of like a placeholder, and say that, okay, this string is going to be supplied by a parameter after the format string, and then argv1 equals to %s, argv2 equals to %s. So this is called a format string. So anything that is not preceding with a % symbol is simply, verbatim. And anything that has a % symbol preceding it is what we call a placeholder. Okay, there are many names here, but I just call it a placeholder. So the placeholder value is now specified as additional parameters to printf. So we just specify argv0, argv1, and argv2 like that. Okay. So this program obviously doesn't do anything actually useful, but I want to know what it looks like. Okay, what is argv1 and what is argv2 as a string. So I go ahead and specify the language. Okay, and it's a C program, and I go to debug, and it complains about, oh, I keep missing semicolons because I've been writing JavaScript a little bit too long. There we go. Okay, so we can now do it again. All right, so now it puts you into the debugger. When you're in the debugger, you can run the program, okay? But don't just run and then press the enter key, because you have to supply the additional arguments. So I'm going to specify 2 and 3 respectively like this, okay? Because that's how you specify the arguments to a command line program, okay? You just, yeah, go ahead. Question?
So we are making the value 1 sub 1 sub 0 sub 1 sub 2, all of them as strings?
Yes. So they are given to you as strings already. So when I run the program, the output of this program is right here. You can see how argv0 is /home/a.out. So this is the path to the executable, which is useless to us. And then argv1 is just a string with 2 as a value of it, and argv2 is just 3 as a string in it.
Okay.
All right. So obviously, as a string, it is not particularly helpful to you because you need to actually extract the numerical value of that. So to extract numerical value from a string, there are several ways to do it. Okay, you can write your own. Okay, you're definitely free to write your own subroutine to parse a string into its numerical integer value. That's fine. But if you don't like doing that, okay, you can use a built-in functions, because they're all part of the C standard library, and you are allowed to use anything that is quote unquote standard to C in this case. So they're called ATOI. Okay, one is called ATOI, and this is the man page or the manual page of that. So to use this, you basically just pass a string to ATOI, and it returns an integer value corresponding to the string. Okay, so now we go to here, and then we add oh, okay, I have to, so before you change the program, you have to stop it first.
So are we allowed to use the standard C++ string library?
Yeah, you can do that.
Okay.
Yep, as long as if it compiles in online GDB, it should be fine, because that means it doesn't need any special linking consideration. So we have stdlib.h in this case. So now I can say, okay, use two local variables. Go ahead.
Chat.
Huh?
Can you put the link to the website in the chat just to make sure?
You mean online GDB?
Yes, to make sure we go to the right one.
You can code in C, C++ at onlinegdb.com. There we go. And let me check out the other languages. It does have other language support of other languages too. So you can do it in Java. You can. PHP is not on the list, and none of these other ones are on my list either. Okay, yeah, so only C, C++, and Java are the ones on the list. But if you want to do it in Node, you can download and get a Node environment for free. All right, so we want to extract the two integers. One is the number of trials, which is the first one, and then the other one would be the number of elements in as available choices for the first one. So I'll just call this number of choices. So now we just have to say num trials is ATOI. Basically it's called ASCII to integer, and then you just have to give it argv1 in this case. And then the other one is kind of the same deal. Num choices is ATOI argv2, like so. Okay, and obviously you can try to printf again. Okay, but I'm going to show you guys one thing that is even more helpful. Okay, and it is using the debugger. Okay, because printf is okay, but it really is not the best way to debug a program, especially when you're dealing with a program that potentially has recursion, and then you have loops within the recursion. I mean, printf is just going to kill you. Okay, that's not a very good way to debug a program. So the best way to debug a program is to utilize the debugger. Okay, but I have to be able to specify something here so that the debugger there's a way to stop it here at this point. So I need to do a, okay, here we go. So we'll go ahead and then have void f, okay, and we're going to call function f, even though it's useless, just so that I have a way to a place to put a breakpoint. Okay, so I go debug the program again, okay, and run, and then I specify, okay, let's just say that I want 13 trials, and there are 24 items available for the first trial. Now, if you try something like this, your program is going to take a while to finish, okay, because 24 choose 13 is a pretty big number. All right, so we run the program. Oh, I forgot to specify a breakpoint first. Sorry. Okay, let's put a breakpoint. So if you want to set up a breakpoint, there are a few ways to do it. One is just to use the GUI and click on a line like this, And when you see a red dot next to a line, that means we have a breakpoint on that line. And you can toggle it. In other words, if you click it again, it disappears. Okay. So I want to put a breakpoint here. You can also see where your breakpoints are. You can insert as many breakpoints as you want. And in this case, we have breakpoint number 2. It is on line 24 of main, and it is currently enabled. You can disable it just by unclicking it, or you can get rid of it by clicking the X button here. I mean, you guys know how to use a GUI. So we'll go ahead and run the program again. Okay, run 13 and 24. Press the Enter key. And you can see the printf, the first printf, that we put into here on line 21. It is still here. Okay, so it's telling us that the first string is 1, 3 as a string, and then the other one is 2, 4 as a string. As strings, they're not really that helpful to me. I want to know the numerical values. So by the time I get to the breakpoint, which is on line 24, the operations on line 22 and line 23 are already done. So now I can say, I don't even need to print it, right? I mean, that's so. I'm kind of archaic, okay? I'm not used to GUIs, okay? So all of these nice things are new to me, because you can see it automatically tells me what my local variables are at this point in this scope, and it's telling me that num trials is 13 and then num choices is 24. All right, so and you can assume that I'm not going to trick your program and not give it enough arguments or give it two wrong arguments. So you don't have to check, okay, whether there are 2 additional arguments, and also whether those are numbers and the first one is less than or equal to the second one. You don't have to check that, okay? I'm telling you that when I test your program, I'll give you proper input values. So no need to worry about that. Well, thank you, Aaron, for the link. Okay, there we go. So this is all we need as a starting point, because once we know the number of trials and also the number of items, for the first trial, the rest is going to be your code. Okay. Now, before you get started on this one, I also want to point out that this program technically doesn't need to be very complicated. In other words, all the stuff that we talked about today, okay, let me just kind of go back and talk about that a little bit. This stuff here, and also the recursive definition here, your program still needs to be recursive, okay? So that part cannot be avoided, okay? And within the function, okay, whatever function you want to name for the big U thing, that still needs a loop in it, okay? So it's not possible to avoid having a loop, nor having your program to be recursive, okay? But beyond that, okay, you may be able to get away without having to have a representation of a set, okay? I'm not limiting you in terms of how many arguments you can use in your recursive function, so you can actually have as many parameters as you think is necessary, okay? And as a result of that, okay, there are ways to make your program a little bit easier to deal with. And the best way to do this is to kind of do something by hand first, okay? So when I say do something by hand, I am saying, let's just say that you're starting with A, B, C, D. Okay, so this time we have 4, and you want to have, let's say, 2 trials. Okay, so you kind of know what the output is going to look like, right? Okay, you say, okay, what if I choose A first? Then I have B available as the second one. I have C available as the second one. I have D available as the second one. Then you move on to A. You move on to B, right? But since we have already exhausted everything that can have A in it, so that means I don't have to look at A anymore when I move on to B and go like, okay, what can B pair up with? Pairing up A with B was already explored. So I can now say I can start with C, and I also have D, right? And now when I move on to C, I already know, because I do everything using alphabetical order, so I know everything that can possibly pair up with A is already done. All combinations that has A in it, done already. Everything that has B in a combination, done already. So when I get to C and ask, what else can pair up with C that I have not considered yet? That can only be D. Okay, and that's it. Okay, this is there are only 6 combinations if I want to choose 2 things out of 4, and these are the 6 of these are the 6. Okay, so this is telling you that there are ways to do this without having to resort to actually representing everything as sets. Okay, I'm just giving you a clue here. Okay, I'm giving you a clue to basically say your program doesn't have to be following the tedious steps that I talked about today, and you don't need to have a full implementation of the set union and all the other operators in a set, because the outcome just needs to be something like this. Now that being said, okay, when I test your program, I can test it all the way up to choosing like 25 items out of 26, choosing 22 items out of 26. There's no limit. Okay, as long as the number of trials is less than or equal to the number of items that you can have in the first trial, and the number of items you can have in your first trial is up to 26. As long as those rules are in place and I respect those rules, I can test your program any way I want, okay, within that huge space of test cases. And your program needs to work in all of those test cases, okay? All right, so are there any questions about the homework assignment? Okay, all right. So what I have talked about today is kind of important, okay, especially the very last bit that I just went over, because that can significantly reduce the complexity of your program. Now it still has to be recursive, and it's still going to have a loop inside the recursive subroutine, but other than that, there are ways to make it like really nice and not complicated. Okay, all right, so I think we're good. All right, thank you. And the next hour is kind of my office hour, so I will be accessible during this time if anyone has any questions. Oh, by the way, one more thing. I think I might have mentioned this already. Next Thursday, there's no lecture on next Thursday, and instead we are going to have a presentation. Oh, I think my kitty is.
Oh, is that what having the general?
Yes. So General E and his team, is going to have a presentation next Thursday. So we won't have a lecture. Instead, we'll have General E, talking about DISA, which is basically the IT department of the Department of Defense, and a few and then some. Okay, but it's going to be interesting. So next Tuesday we're going to have a practice exam for exam 2, because we need to get exam 2 done before Thanksgiving. So exam 2 is going to be 1 week after next Tuesday. Is that okay? So next Tuesday we have a practice exam. Next Thursday we have General E's visit, and then the Tuesday after that we have the actual exam 2.
So we have a practice exam and then an actual exam.
Yes. Just like you with the first one, I give you a practice one, and then we have the actual one 1 week after. All right.
Will this also be through Discord, or is this going to be through Zoom?
Oh, I guess I did not. Oh, actually, I have the tab over right here. Okay, so it is not going to be over Discord, because I'm expecting a lot of people, a lot of participants, and Discord will only let me have up to 25 participants. And I think we might end up with possibly 100 people, actually listening in. So I'm going to do the usual thing. I'm going to give students the YouTube stream link here. And then the presenters and myself will be doing this not using Discord, but we'll be doing this over Google Meet, because Google Meet can enable closed captioning. Yeah. So the actual presentation is over YouTube, but it's going to be a live stream, so it's going to be about 15 seconds, behind the actual real-time thing. And I'll be collecting questions from the text channel on YouTube. And at the end, if there's enough time, okay, I can then present those questions to the presenters, and hopefully they'll be able to answer some of the questions. Yep. So that's kind of the schedule for the next week and a half or so. I just want to make sure that everybody know about that. All right, so if there are no further questions, I'm going to stop the stream for today, and have a nice weekend, everybody. It's going to be a very interesting weekend because of the election, but stay safe. Yeah, exactly. Yeah, but stay safe, and just kind of take it easy. Any way it goes, just take it easy. All right.
Have a good weekend, Ty.
Yep, same to you. Thank you. Okay, bye.